Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
They are among the biggest explosions of radio energy in the entire universe. They generate more energy than 1 billion suns.
As we contemplate the sun, we are aware of its enormous power and the energy it emanates throughout our solar system. This radiant star, a blazing ball of nuclear fusion, sustains life on Earth and dictates the rhythm of our days and seasons. It is hard to imagine anything capable of surpassing our sun. Yet beyond our own star lies a cosmic wonder that makes even the mightiest solar giants seem insignificant in comparison. Betelgeuse, the red supergiant, defies explanation with its enormous diameter, irregular pulsations, and unpredictable behavior. This enigmatic star has fascinated astronomers for centuries, presenting mysteries that challenge our understanding of stellar evolution. The star is an enigma to scientists who are still studying its power and potential. As they investigate this magnificent star in depth, they have discovered something terrifying. Join us on this journey as we delve into the constellation Orion with the James Webb Telescope and explore how its arrival could change our understanding of the universe and its impact on the cosmos. This exploration promises to unveil new insights into the life cycle of stars and the dynamic processes governing their transformations. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Stay connected with us for more fascinating discoveries and cosmic adventures. Although many people are unaware of this fact, it is possible to spot Betelgeuse in the night sky during the winter months in the northern hemisphere. This bright, ruddy star stands out even to the naked eye, a beacon in the cold winter sky. Just look up at the sky and focus on the constellation Orion and Canis Major to see this dazzling star in all its splendor. Orion, often referred to as the Hunter, is one of the most recognizable constellations, making Betelgeuse relatively easy to locate. There you can easily locate the reddish-orange star that marks the upper left corner of the rectangular shape of the constellation. This distinctive color and position make it an intriguing object for stargazers and amateur astronomers alike. The star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you have looked closely at this star, you will have noticed that it does not remain constant. In fact, it varies in brightness periodically. This variability is a characteristic feature of red supergiants, reflecting complex internal processes. This peculiarity is no coincidence since Betelgeuse, as the star is called, is no ordinary star. Its massive size and advanced stage of evolution set it apart from the myriad of stars in the night sky. Although to us it may appear just to be one more in the vast firmament, it is located at a distance of more than 640 light-years from us. This distance, while immense, places Betelgeuse relatively close in astronomical terms, making its study particularly significant. At first glance, this figure may not seem impressive, but in reality, it represents an enormous distance. To illustrate this magnitude, let's imagine that we could travel at the speed of light, which unfortunately is not possible. Even in that hypothetical scenario, it would take us more than 640 years to reach Betelgeuse. Such a journey would span generations, highlighting the vast scales involved in space exploration. If we wanted to undertake such a journey in a spacecraft, even using our most advanced technologies, it would take us more than 12 million years to reach it. This figure far exceeds the entire history of human civilization on Earth. Such an expedition would stretch far beyond our current technological capabilities and lifespans. However, the scarcity of light from Betelgeuse is not only due to the distance that separates us from it. The star's inherent properties also play a crucial role in its visibility from Earth. Betelgeuse is what is known as a pulsating red supergiant, which means that it is an ancient massive star that undergoes expansions and contractions. These pulsations are driven by the complex interplay of nuclear fusion and gravitational forces within the star. During these cycles, its brightness can vary in the night sky, becoming more intense or dimmer. These brightness changes can occur over extended periods ranging from tens to hundreds of days. This dynamic behavior makes Betelgeuse an object of continuous interest and observation. The amazing thing is that Betelgeuse can oscillate in brightness over a wide range. It can range from near magnitude 0.5 to reach 0 magnitude, making it extremely bright. These changes follow cycles, with the shortest being 185 days and the longest being 2,335 days. Such variations provide valuable data for understanding the underlying mechanisms driving these fluctuations. At certain times, Betelgeuse can become quite faint, which is called its minimum magnitude. In February 2021, it was reported to present its lowest minimum magnitude in a long time, reaching a magnitude of plus 1.614. Although relatively bright, it is definitely fainter than how we usually observe Betelgeuse. This dimming event sparked widespread interest and numerous studies to unravel its cause. However, brightness is not the only outstanding feature of the star. Betelgeuse is known for its distinctive reddish color, which is due to its cool surface, which has a temperature of about 3,500 Kelvin. This cooler temperature is a hallmark of red supergiants, contrasting sharply with hotter blue stars. This temperature is much lower than the surface of our Sun, which reaches 5,500 Kelvin. This lower temperature means that Betelgeuse emits much less energy per unit area compared to the Sun. That is why, despite being one of the largest stars we know, it appears much dimmer. The vast size of Betelgeuse, combined with its lower temperature, gives it its characteristic reddish hue. Betelgeuse is like that giant that is satisfied with a low profile and doesn't need to show off its size to feel important. Its serene glow in the night sky belies the immense energies at play within. However, don't be fooled by its appearance. Betelgeuse is a supergiant star that is about 20 times the mass of our Sun. This is one of the reasons why this star has been the subject of numerous studies over the centuries. Its colossal mass and evolutionary stage make it a key object for understanding stellar physics. It has been a prominent object in the night sky and was first identified by the ancient Greek astronomer Hipparchus. Its name in Arabic means the Orion's armpit, reflecting its position in the constellation. Although not much could be known about Betelgeuse at the time, modern telescopes have enabled researchers to study this phenomenon in greater detail. Advances in observational technology have opened new windows into the star's complex structure and behavior. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties, such as its size, temperature, and composition. The Hubble Space Telescope, for example, has provided detailed images of Betelgeuse's surface, revealing intricate patterns of gases and dust. These observations have allowed researchers to create models to understand the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Millimeter/Submillimeter Array ALMA, a state-of-the-art observatory located in Chile. ALMA has provided high-resolution images of the surface of Betelgeuse, revealing details about its structure and behavior. These cutting-edge instruments continue to enhance our knowledge of this stellar giant. One of the most remarkable discoveries made by ALMA is the presence of an extensive plume of gas extending from the surface of the star. This plume is believed to be caused by pulsations from Betelgeuse. These pulsations can be explained by a process called convection, involving the rising of hot gas and the sinking of cold gas. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. This dynamic process contributes to the star's variability and complex behavior. Thanks to the Hubble Space Telescope, detailed images of Betelgeuse's surface have also been obtained, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict how it might behave in the future. Such detailed studies help refine our models of stellar evolution and supergiant dynamics. In addition, Betelgeuse's surface is marked by dark spots, also known as star spots or magnetic spots. These areas on the star's surface exhibit particularly strong magnetic intensity. These regions, known as star spots, are areas on the surface of Betelgeuse that are cooler. This is because the star's magnetic field inhibits the flow of gas from the interior to the surface, creating a cooling effect. These spots can provide insights into the magnetic activity of massive stars. As a result, the spots appear darker compared to the rest of the surface. Betelgeuse's magnetic field is believed to be thousands of times stronger than that of the Sun. This intense magnetic field causes the gas on the surface of the star to be trapped in loops or arcs, describing regions of intense magnetic activity that are visible as star spots. These magnetic loops can extend far into the star's outer atmosphere. It is important to mention that the presence of star spots is not unique to Betelgeuse, as they are also observed in other stars, including our own Sun. The star spots in Betelgeuse are especially interesting because of their size. They are several times larger than Earth and cover up to 20% of the star's surface, which is significantly larger and more numerous than the sunspots on the Sun. These star spots can affect the overall brightness of the star and cause variations. Their dynamic nature provides a window into the turbulent processes occurring within the star. As the spots move in and out of view, Betelgeuse's brightness can fluctuate. This is because the spots, being cooler, emit less light than the surrounding gas, which contributes to changes in the observed brightness of the star. In the case of Betelgeuse, pulsations of the star also contribute to the brightness variations. As the star expands and contracts, star spots move in and out of view, further amplifying the star's observed brightness. These interactions make Betelgeuse a fascinating subject for studying stellar magnetic activity. The surprising thing is that Betelgeuse is not as unique as one might think. While there are not many stars like it, there are some that share certain similarities and are equally fascinating. These stars provide valuable comparative data for understanding the life cycle of massive stars. One of Betelgeuse's cosmic cousins is Antares, a red supergiant located in the constellation Scorpius. Antares is also a variable star, meaning that it undergoes changes in brightness over time, just like Betelgeuse. Such stars help astronomers develop broader theories of stellar behavior. In addition, Antares has a mass approximately 12 times that of the Sun and a radius that is 700 times that of the Sun. Its characteristics offer another perspective on the life and death of massive stars. So it's safe to say that Antares is no match in terms of size. However, it still plays a crucial role in expanding our understanding of the universe. Now, what do you think? Do you think Betelgeuse has already exploded and it's just a matter of time before we see it in our skies? Let us know in the comments box. Engage with our community and share your thoughts on this cosmic mystery. If you like the video, like and subscribe to the channel. Your support helps us continue exploring the wonders of the universe. Thank you so much for watching. See you soon. Stay curious and keep looking up at the stars.